let me start. Actually, let me start with this. This help support, as you correctly mentioned. The name of this session is basically Kubernetes in Dagger. Seems like running nested things is the nemesis of any containerization platform. Dagger in Dagger, Kubernetes in Dagger, now GitHub Actions in Dagger in GitHub Actions. But this started as a user requesting. I'm going to share the links afterwards. As a user requesting the ability to run Kubernetes in Dagger, mostly because they have like pipelines running Helm charts that they want to test. As many of you probably know, GitHub Actions already has a way to run like Kind or K3s or other tools in their platform, which is of course very tied to their Actions marketplace. So far, because you need to run some checks in order to see that the Kubernetes cluster is up. And yeah, basically this started a thread in our Discord channel about different possibilities of running this, which led to an issue in our open source repo, right, about how to accomplish this. And what I would like to show you now is I would like to go backwards from the working solution because this is going to be a very handcrafted live demo, unprepared. So we'll start from the working solution, and then there's going to be a lot of knowledge in the steps that we took in order to like troubleshoot the different things that were happening with this and the discoveries that we did along the way. This issue is not yet closed, I think, because there's always better things to do this. But I would like to show you the current state of things and as well here some thoughts or maybe some other additional features that you would like to see on top of this. But the gist is that I have a Dagger pipeline, which is along the same lines that the ones that you're going to see on this issue. But basically, there's a main function, which basically connects the engine. And then the different users have been modeling this K8s basically service, if you want to call it that way, in Dagger. So we have a struct, right, that instantiates, makes use of the Dagger service. In this case, we are using K3s as a service for this pipeline. We are mounting some folders. I'm going to explain later why we need to do this right now, and like this. And then basically, I'm just starting the K3s server. I'm binding a specific IP address, which I'm going to explain why we did this as well. We are disabling some K3s modules, which are unnecessary for us, like traffic and metric server, which are additional components that K3s basically bundles by default. And then we are creating a container with a kubectl, 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 eternal discussion. We are mounting the config that K3s service produces. And this is because, as some of you probably know, when K3s starts, it writes a config file in their own file system with the certificates and the kubeconfig file needed to connect to that cluster. We basically are writing that into a cache volume and then mounting that in the kubectl container. We are binding the service using the Dagger services feature. And then we are disabling cache, mostly because every time that I run this pipeline, this is going to spin up a new Kubernetes cluster. And if I don't comment this, then Dagger is basically going to cache these operations because basically the instructions don't change. And it's going to reuse an old kubeconfig file, which is basically going to complain because either the IP is going to be different or the certificates are going to be different. So I need to basically validate the cache for this. And this container basically gives me an entry point with a sage that I can that I can send commands afterwards in hopefully kubectl that are going to allow me to run different commands against the cluster. So continue with our main function, we basically instantiate this Kubernetes service. We started, and then since I get like a K3s instance, which is basically wrapping up a container execution under the hood, the Dagger container execution. In this particular case, I do a get pods, right? And then afterwards, we do a get services to basically validate that this is working. One other thing that the start method does is basically it loops, because as you know, like Kubernetes needs to like boot up and then make the nodes ready and basically spin up all the core components like the API server, the scheduler, and all that. This basically loops until it checks that the nodes are ready, and then it basically gives control back to the program, so we can continue executing our pipelines. So that's pretty much it for this part. Let me just run this pipeline so you can see that it actually works, and then I'm gonna start going backwards to show you how we the problems basically that we came up with when trying to make this work, as well as the different solutions that myself and the team have been working on to make it work. Another minor thing is that, well, as you can see, this already ran, which is surprisingly fast. To spin up a new Kubernetes cluster, as you can see here, I'm basically querying the nodes, and I have my node where the node is not ready yet because the components are being started, and then I have all my Kubernetes services here at the same time. What I was saying is that we are basically we are making use of Dagger services, as I mentioned, and we are exposing the API server port, which it's basically being picked up automatically by the kubeconfig. And then because we are binding the port here, basically this step of the pipeline executes as long as the API server is ready, as soon as the API server is ready. And then I need to do the waiting part because the API might be up, but then the Kubernetes cluster might not be up, might not be ready. So I basically need to run this part afterwards. So this runs. I can also prune the cache. I'm going to do a build cattle prune. I'm going to remove everything and do it again. So you can check, go run. Yeah, Dagger run, go run. So you can check that from the very scratch. This is also very fast because I'm basically pulling the raw images. This should take a minute. But so basically going backwards, I would like to show you why we did certain things and how we basically checked that those things were actually working or not. The first thing that I would like to show you is that the reason why we mounted these files here is because if we don't do this, right, which is the thing that you would do by default. So let's wait for this to finish. Basically, if we don't do this, we are going to get an error when trying to run Kubernetes, because K8s, when bootstrapping Kubernetes, is going to try to use overlay FS by default, which is basically the snapshotter that containerd and runc uses. And when it tries to do that, since Dagger already runs containers in an overlay FS file system, because basically we need to snapshot all the operations that happens there, that is not possible to do overlay in overlay. Same issue as Docker in Docker or any other overlay in overlay. And I was getting an error basically. So if this finished, as you can see from the very beginning, the node is ready, as you can see. So let me do Dagger run one more time, and you are going to see that basically the bootstrapping process never finishes, and the pipeline finishes with an error because it is not able to connect to the Kube API after the max retry count. So let's see if this is pulling the image or running. So yeah, basically this returns an error. Now it must be probably trying to run this, and because it cannot start, it's going to fail eventually. Or my internet connection is not good enough right now because I can't resolve the image. Let's see. Yeah, seems like. Can you hear me? Just trying to make sure that.
Yes. Yeah.
Okay, cool. Just trying to make sure that my internet connection is still alive. Okay, now it started, and now you're gonna see that I basically copy the kubeconfig, and basically the cluster is not gonna start. But if I basically stop this and I look for overlay, you're gonna see here that I'm not able to start K8s because failed to mount overlay. This is the overlay in overlay issue that I was mentioning. And so this is one of the things that we had to fix. And the reason why this worked initially, like what you would be basically aiming to test. If you do a Docker run of the K3s image and you start this, you're going to see that this is going to run out of the box. And then probably you're going to think of, okay, why this works in Dagger, in Docker using privileged container, but it doesn't work in Dagger, even though I'm using the insecure root capabilities, which, by the way, I didn't mention this before, but because you're running a privileged service as a K3s or Docker or anything else, you need to supply this argument, which is basically going to allow the service container to access C groups and like more advanced capabilities that it needs. But if you run it with Docker, then you're going to see that it works out of the box, and you're not going to get this overlay issue that I was saying. But why is this? This is because if you inspect the Docker image, I think I have the inspect command here. Yeah, if you inspect the Rancher image, you're going to see that it automatically has some volumes defined in the image config OCI spec, which Docker automatically picks up and mounts them without you realizing that this is happening, right? Which makes me think, I don't know if you have an issue for this in Dagger, but which makes me think that we might do the same as well. We could do the same in Dagger, like automatically mount this as cache volumes, or maybe tempfs, I don't know. But it's different models, you know, on how Docker works and Dagger works. It's for different purposes. But yeah, this is why it works in Docker by default. So yeah, basically once I mounted this here, I could bypass basically the issue of, you know, like the overlay, and this works. The other aspect, which was a bit difficult to get it to work, was the IP thing, right? And now we're going to do some network troubleshooting. If I remove this bind address here, and I start the K3s as it is, what's going to happen is that K3s by default sets up, even though it listens in all interfaces, right? So you can connect from anywhere. The config file that it generates is going to say localhost, because K3s is initially thought to be run in a standalone server, not in containers. So basically, when this pipeline container tries to access K3s, it's not going to be able to unless we do some, you know, file replacement with sed or something else to like replace the IP. It is not going to work. Not going to work. So initially, you know, we were trying to troubleshoot this because we didn't know effectively if like K3s was actually listening on the proper interfaces or not. So the way that we troubleshoot this, and thanks Alex for this tip, is that we let me increase the retry backup. So I'm going to basically increase this retry backup so the pipeline keeps running for a long time. And then I'm going to run this. And you're going to see that the wait for nodes is never going to finish because it's not going to be able to connect to the K3s cluster because of the IP thingy. But what I can do, and this mostly applies to Linux and WSL2. It's not going to work in Mac. But I can do pgrep K3s, so I can check which process ID K3s has, and then I can do the famous nsenter command. Yeah, if I do nsenter, and then I supply the PID, and then I want to join the network namespace, and I can do netstat ppnl netstat, or maybe the process change. Yeah, seems like it's a different process. Oops, sorry, wrong copy. Trying again. Okay, as you can see now, I'm in the network namespace of the K3s container, and we are gonna supply better ways of troubleshooting this in Dagger, but you can do this in the meantime. And you're gonna see that the K3s server is running, and what we validated with Alex when troubleshooting this was that, okay, K3s is effectively listening on all interfaces, even though I'm basically, the config file specifies localhost, right? So basically, If I go and check this config file in this container, it's going to say localhost. So that's why it's basically, well, actually you can see it here. The error says that it cannot connect to localhost. And the way that we found to basically bypass this, even though it's not very elegant, which we could improve in Dagger, by the way. I think we have like a discussion about this. It would be great if the service container basically could inject some metadata to the underlying dependent containers about the host name or the IP of the server. And the reason why we cannot use this name in the kubeconfig file is because of the certificates. So we would have to change the way that K3s starts. So we could add basically a host name to the certificate instead of the IP, which maybe complicates a little bit more the pipeline. But yeah, what we are doing here is basically using the bind address flag of K3s. We are getting the IP that gets assigned to the service, and we need to do this dynamically because every time that you run the pipeline, the IP might change because of the way of services work. And then when we do this, K3s automatically gets the bind IP address and puts that in the kubeconfig, right? So you don't need to change anything else. That's going to work out of the box. And we can double check this. Like if I run the pipeline again and I'm fast enough, let's see if I can show you this. pgrep K3s. I have the PID ID, and then if I do the netstat fast enough, yeah. So now that I have the netstat, you're going to see that the API server of K3s is actually running on the proper IP and not all the interfaces as it was before. This is the IP of the container. Cool. So we managed to troubleshoot this, and the pipeline finished. It's already working. The last thing that I wanted to share is that we of course need to bust the cache on every run, because since we are using a cache volume between the service container and the underlying dependent containers for this, otherwise this would reuse an old kubeconfig configuration, right? Which is going to have the wrong IP and the wrong certificates. So this is not going to work. So we basically need to invalidate the cache here. And because the way that this pipeline is structured, you can exec multiple commands on top of the container, basically to like do whatever you need to do. We need to bust the cache here as well, because these commands might not be different each time that you execute them. So we basically need to make sure that this gets executed multiple times. Lastly, imagine that you wanted to run a pipeline and ultimately assess the state of your Kubernetes cluster, because you want to see what was left over after that. There's another way that you can do this using NSCenter, as I showed before, which is imagine that after my pipeline finishes, I'm going to do like time.sleep, and I'm going to do I don't know, 5 minutes. I'm going to run this one more time. And what you can do once you get the, again, K3s process ID, and let me reiterate that we do have something in progress to like be able to troubleshoot containers easily in Dagger. So keep in mind that we're working on that, and hopefully show something soon. But what you can do in the meantime, instead of attaching yourself to the network namespace, you can do all --all, and if you do a PS here, you're going to be inside that container. So I can do basically kubectl get bots. Sorry. And I think that the process died, maybe. Yeah, the process died. So basically, if you do all and you're inside the container, you can run any binary that is inside the container, because you're inside the same mount and PID namespace as that container. So basically, you can start cutting files, running processes, or whatever you want. Let me see if I can get this real quick. Otherwise, we can wrap it up. One more time. Yeah, as you can see, I can list all the pods, I can list all the nodes, and keep troubleshooting this. Okay, now it finished again because of timeout issues. Yeah, so of course this is going to run the same way it runs in my machine as in any CI system. The thread that the issue that we have in GitHub is mostly around running Helm CI pipelines of like basically verifying that Helm charts also work. And we are going to probably be using this soon ourselves as well as part of Dagger, because we have some Kubernetes stuff there as well. So yeah, hopefully this unblocks people trying to use Kubernetes locally and your CI systems. And if you have any other questions or things that you think we could do on top of this, happy to hear them. Yeah, that's pretty much it.
Thanks, Marcos. And then when we add this to the demo forum too, I know we have a few issues related to this, like you mentioned, kind of like the roadmap of next steps. So I'll make sure that we add those GitHub links so you can start to follow those as we make improvements for this. And as you mentioned, we are trying to focus on building a lot more Kubernetes documentation. So if there's a specific use case or anything you're wanting to see around that, we'd love to hear it. Okay, let me check. I think there might have been one Q&A that came in. Oh, no, perfect. Okay, that got answered. Thank you, Jeremy and Solomon. Okay, well, thank you everyone for attending. We really appreciate your time and being able to join us today. We will see you for the next community one in 2 weeks. We do have a really fun MLOps demo for next community call. So if you're some MLOps fans, let people know and it'll be a fun one to join. Thank you again, Robert and Ali and Marcos, for being here. Appreciate it. Have a great day. Bye.